This video explains stress analysis example 29, contact analysis of two cantilevers. The upper cantilever is forced to bend and contacts the lower cantilever. First, obtain the project file from the example topic in Femtet Help. Opening the file directly will cause an error, so please save it first and then open it in Femtet. Check the settings for the analysis space. Model unit is millimeter. Analysis space is 3D. Check the analysis condition settings. Stress analysis is selected as solver. Static analysis is selected as analysis type and large displacement option is selected in stress analysis tab. In step/thermal load tab, single step is selected. Substeps is set to 40 in step/reach temperature setting. In options for the non-linear analysis, both save the results of substeps and add unloading step are selected. Let's review the modeling procedure. The History tab in Body Tree records the drawing history, allowing you to review the drawing steps by using undo and redo. In this example, you can see that the process begins by creating two boxes, setting their body attribute and material constants, and then applying boundary conditions. Check the body attributes and material constants. The two cantilever beams have been assigned the body attributes body 1 and body 2, and the material constants mat 1 and mat 2. The material mat 2 for the upper beam is set to an elastic material, while the material mat 1 for the lower beam is set to an elastoplastic bilinear material. Clicking the graph display button displays the stress-strain graph. The yield stress is set to 8 megapascal. Check the boundary conditions. In this model, 5 boundary conditions have been defined. First, the displacement boundary conditions fix_all, fix_y, and down have been set. Fix_all completely fixes the bases of the two beams, so the displacement in all XYZ components is 0. Fix_y is applied to the sides of the two beams to restrict displacement in the y direction. Only the y component is set to 0 displacement. Down is a boundary condition designed to bend the tip of the upper cantilever beam downward. It applies a displacement of -1.5 mm in the z direction. The remaining two boundary conditions, contactor and target, are contact surface boundary conditions applied to the contact surfaces of the two beams. Contactor is set as the contactor surface and target is set as the contactee surface. Run the analysis and review the results. Select Mode 39, Step 1, to display the displacement gradient contour plot and the displacement plot. You can see how the two beams deform while in contact. Play the animation. You will see that, after Step 1, the upper beam returns to its original position by unloading setting, but the lower beam remains bent. This is because the material of the lower beam is elastoplastic, resulting in plastic strain. By setting the field type to plastic strain and display the element vectors, you can observe the changes in plastic strain. You will see that even after the upper beam returns to its original position, plastic strain remains in the lower beam. Be sure to save your project when saving the analysis results. That concludes this video. Thank you for watching.